BCIS 1305. My name is Dr. Schuessler, and this is the very first chapter of the textbook that we're going to be using this semester. And it covers the material over digital literacy. So let's go ahead and jump on in and take a look at that. Okay, so the objectives for this chapter include being able to differentiate among laptops, tablets, and servers. I think most of you probably have a pretty good idea, particularly with respect to laptops and tablets, but we'll talk a little bit about that. Servers as well, we'll talk about that and talk about some of the differences in terms of software and hardware and stuff like that. We'll describe the purpose and uses of smartphones, digital cameras, portable media players, ebook readers, and game devices. I don't think there's a lot of black magic there. We'll describe the relationship between data and information. That's a concept that a lot of students tend to struggle with. The distinction between data and information. They don't sometimes have trouble understanding why there's a difference or how they're different. We'll briefly explain various input options. Sometimes students have trouble relating input devices and output devices and how those are related to information systems. We'll differentiate the internet from the web and describe the relationship among the web pages, web pages, websites, and web servers. We'll explain the purpose of a browser, a search engine, and an online social network. We'll briefly describe digital security risks associated with viruses, other malware, privacy, health, as well as the environment. We'll differentiate between an operating system and applications and talk about how some other techs deal with this. We'll differentiate between wired and wireless technologies and identify reasons individuals and businesses use networks. We'll discuss how society uses technology in a variety of different fields, and we'll talk about some of the different users of technology. Okay, so a world of technology. Because technology changes, you got to keep up with it. It's constantly changing. It really doesn't matter what field that you're in. Everybody's lives are touched by technology, whether it's education, whether it's healthcare, automotive. Everybody has to deal with technology in some way, shape, or form. That's where this idea of digital literacy comes in. It's the general idea of how technology works. Doesn't mean you necessarily have to know how to program, though that's certainly not a bad thing. As we discussed in class the other day, somebody like Steve Jobs really advocated for teaching programming to every student because it teaches a way of thinking about things. There's a logic, there's a structure to programming that's beneficial to students in general. Digital literacy, though, doesn't necessarily mean that you have to know those inner workings of a system in order to be able to use it for some purpose. And that's the idea behind digital literacy, is being able to take technology and be able to use it in our daily lives. So with all this in mind, this idea of digital literacy, we're talking about applying technology using a computer. But what is a computer? We look at one, we know what it is, but how do we really describe it? Well, the textbook definition is that it's an electronic device. It's operating under the control of instructions stored in its own memory. The reality is the definition of computers changed over time. If you looked at a dictionary before the 1930s, it would specifically identify an individual as a computer. It would be a person that does calculations. Oftentimes these were women, especially during World War II. They were doing various calculations for firing tables here in the United States or code breaking in Great Britain. And even before then, a lot of computers, rather than being individuals, we had mechanical devices that in a lot of ways mimicked what we do today. If you go back historically and look at some of the machines designed by Charles Babbage, a lot of the same concepts that he came up with are still in use today. So this concept of a computer has been around for a long time. The idea that has really kind of pushed it forward is the need to generate more and more calculations more and more quickly, and so that's kind of where this push came from, pushing it away from individuals doing calculations to electronics, something that could operate much more faster and produce replicable results with fewer errors, or no errors, hopefully. So what are some of the examples of computers all around us? Well, obviously laptops, tablets, desktops. Those are the obvious ones. Those are the things that we typically work with on a daily basis. Servers sometimes, however, are a little bit strange to students. That they're not something that they normally work with directly anyway, and directly and knowingly. A server can be really kind of thought of in a couple of different ways. It can either be hardware, or it can be software, it can be both. But the reality is servers really are all around us. If you have your home network, for example, and you log into your router is running a web server, and you log into that router in order to be able to configure the settings for your home network. Same thing's true if you happen to have a wireless printer. You log into that wireless printer to be able to configure it for use on your network. You're logging into a web server that's in that printer. But again, when we talk about servers, they can be software such as Windows Server 2012. It can be hardware, which is a hardware device, a hardware computer that tends to be more robust than a typical computer. It might have more memory, larger, faster hard drives, dual CPUs, dual power supplies, things of that nature. So they tend to be more robust than your typical desktop or laptop, things like that. Other types of computers, smartphones, digital cameras, portable media players, all of these are different types of devices that take input. Say a smartphone, for example, you dial in a telephone number, that's input. It processes it. In other words, it interprets the keys that you've pressed, the numbers that you've dialed, and then it produces output in the form of sound that you're able to hear that person on the other end. So these are all different examples of computers: smartphones, digital cameras, portable media players, ebook readers, game consoles. They all take input, process it, and produce output. So now we need to talk about this concept of data and information. As I mentioned at the beginning, this is a concept that sometimes students struggle with. The idea that input is simply raw data. The example that I used in class was 2.5, 3.7, 1.8. We throw these random numbers out there and they don't necessarily mean anything. But if we start to average those numbers or sum those numbers or probably average those numbers, look at the high, look at the low, we add names to those, and we refer to those numbers as a GPA. Now we've processed that information or processed that data into information. It becomes something meaningful now. So we've added context to it. So information is data that's been processed and has context. How do we get that information? Well, we've got to produce some sort of input. There's got to be a way to get that data into the computer in the first place. In a lot of cases, that data is already there somewhere. We're pulling it up from a file, so that file can become our input. But for that data to originally arrive in there, it's got to be input into some system in some way, shape, or form. And oftentimes a keyboard is done to do that, whether it's on a tablet, a laptop, a smartphone, a virtual keyboard, whatever. Other forms of input, a mouse. Those are probably your two most common forms of input. Those are the ones that we think of and that just really kind of jump out at us. But the reality is there's a lot of other ways to input data into a system. We can use a microphone, for example, and speak into a system. A webcam is a way of inputting information, images. Scanner's the same thing. We can input an image from a document or text into an image file, so it becomes input. On the other end of the spectrum is output. So we take that data, we process it into some sort of a file. Let's say we scanned an image. We process that information into a PDF file, into a JPEG, a PNG file, whatever it happens to be. So now we've taken that input, we've processed it, and now we want to produce some sort of output. We can print it out on a printer. We can send that as a file to somebody via email. So we can manipulate the image in a program, which is part of the processing component, and then save that as an output to a file. So there's a variety of different things that we can do to be able to produce this output. And as far as the output, where we see that, it could be in the form of a printout that we get on the printer. It can be on a monitor, on a screen in some way, shape, or fashion, whether it's a monitor or a digital camera or smartphone. So these are different ways to get information out of the computer. Speakers are another way to get output. So we hear sound, we have headphones, things like that. That's another form of output that we get from the computer. The book kind of draws a distinction here in this part of the text where it talks about the idea of the separation of storage media versus storage devices. Storage media is the physical place where information and instructions are saved. So in a lot of cases, it's part of the storage device. The storage device is the device that actually does the reading and the writing of that information. So a hard disk, for example, is a combination of both storage media and a storage device. The physical device stores the media. But there are examples where they're separate devices and separate media. So a CD-ROM or a DVD drive and disk are an example of separate storage media and a separate storage device. So data and information, where are some of the places that we can store it, some of the media that can be used? Obviously the hard disk, we tend to take those for granted. It's not something we typically see. It's inside of our laptop, it's inside of our desktop, and we just kind of assume that it's there. It's a fixed size, and assuming we don't drop our laptops, we're usually in pretty good shape. A little bit newer to the scene is the idea or the concept of a solid state drive, which typically has the same form factor as a hard disk. However, it tends to be quite a bit faster. They're really slick little devices. My son has one, and it's a neat little device. It doesn't really have any moving parts to it, so the performance tends to be quite good. While they can fail and do fail, because they don't have any moving parts, you don't have some of those issues in terms of vibration and mechanical failure of the drive. It's very similar to a USB flash drive in terms of the technology, but the form factor is quite a bit different. USB flash drive is obviously a lot more portable, something you throw in your pocket, and makes it a lot easier to kind of carry around. At the same time, the downside is they tend to get lost and things spilled in and washed, things like that. These are also very similar to memory cards. A lot of times you'll see memory cards that are used in phones or used in cameras, things like that. Very convenient, small form factor, and that's kind of nice. You've also got optical discs. Those don't tend to be used nearly as often anymore, but they are still around, and so you kind of need to be aware of those. And then there's my favorite, it's cloud storage. To me, that's just the way of the future. It's a great way to be able to store stuff up in the cloud, be able to access it from any device, and they do a much better job of backing up data than we as individual users do. So cloud storage is just a really, really great option. I personally like Google Drive myself, but there's a lot of other ones that are out there. VirtualBox, for example, or not VirtualBox. The name escapes me off the top of my head, but Microsoft's version of cloud storage. So there's a lot of different options that are out there when we talk about storing data and information. The next concept that the book kind of dives into is this concept of the internet. And in class I drew this distinction between the internet and an internet. The internet is capitalized, an internet has a lowercase i. The reality is there are lots of internets. An internet is simply a collection of two or more networks that are connected. So if you combine two or more networks, you by definition have an internet. That doesn't mean that you can go out there and take advantage of a lot of the things that are out there on the internet. You can access, for example, Chase Bank or Blackboard or things like that. But you have the opportunity to share files and hardware devices across two or more networks. The internet is a worldwide collection of networks that connects millions of businesses, government agencies, educational institutions, and individuals. Something that I want you to be aware of is that the World Wide Web and the internet are not the same thing. They're not synonymous. The internet is really kind of a collection of all the various wires and the protocols that kind of connect all of those different networks together. The World Wide Web is a very specific part of the internet. It's a collection of various hyperlinked documents that connect one document to another. And the advantage to this is it makes it very easy to navigate from one document to another just simply by clicking on a link. However, the World Wide Web does not include things like FTP, File Transfer Protocol. It does not include things like email, at least not traditional email through a traditional email client as opposed to webmail. So the internet is much larger than the internet. The internet is much larger than the World Wide Web. The World Wide Web is a part of the internet. Something else that I wanted to talk about, not really covered in the textbook so much, is that the internet is really kind of a United States phenomenon. It's something that's really kind of developed here in the 60s and early 70s. The World Wide Web, however, is largely developed outside of the United States in Europe, and kind of exploded from there. So there's a distinction between the two. Tim Berners-Lee is really credited with the development of the World Wide Web, but even he took the idea from a person back in the 40s named Vannevar Bush, who had this idea of something called the Memex machine. And it was this idea of a collection of connected pages that would allow you to easily access related documents. A web server is a computer that delivers requested web pages to your computer. So on your client machine, when you open up Google Chrome and you go to pull up a web page, that web page comes from somewhere. A web server, that's its job. Its only job is to manage pages, and it serves up those pages when they're requested. Now, with a lot of this stuff, you have all kinds of various concerns, but here's some of the things that you'll see from a web server. A web server is going to serve up a page, and that page can include graphics, it can include different links, it can include video, it can include text links, audio, all kinds of stuff that can be served up from a web server. How do we consume those on our client machine? Through some sort of a browser. A browser software that enables users with an internet connection to access and view web pages on a computer or mobile device. There are several different examples of browsers. The first commercial browser or widely distributed browser was Mosaic. But there's a variety of other browsers that exist today. We went through Netscape Navigator, for example. Internet Explorer is obviously a big popular one from Microsoft. I personally prefer Chrome, but there's a lot of others out there as well. If you're on an Apple device, chances are you're probably using Safari. There's others like Opera. There's just a lot of them out there. So a browser, again, is just a piece of software that allows you to consume web pages under the assumption that the web page is a static web page. In other words, it's not something that changes. There's nothing that's updated on that web page. It's probably just an HTML or HTML file. In that case, all it really is a text file. There's nothing really fancy about that web page. What makes it visually appealing to the user is the web browser. The web browser interprets various tags in that text file to be able to produce that very rich and very nice environment that you see in your web browser. Search engines, there's pretty much Google and then everybody else. It has not always been that way. Yahoo used to be an extremely big player in this area, but the reality is Google is king today, and for the foreseeable future they probably will be. They're extremely good at what they do. Search engine basically uses something called a web crawler to go out and crawl various websites, web pages, to kind of interpret based on keywords, based on meta tags, what the content of those pages and sites are. And it categorizes them, catalogs them, and makes it so it's very easy for us as consumers to be able to access and find that information. As far as social networks, it's also something that's become quite larger on the internet over the last several years. Obviously, Facebook's king in this area. There's others out there. There's Twitter. There's YouTube is considered a social network because they have online comments. There's certainly a social media component to Amazon in the sense that you provide book reviews and things like that. So social network is something where users get together and they interact in some way, shape, or form. They're social. They talk about things. They review things. They produce stories or share photos or all these different types of things. So that's all there is to a social network. It's this group of people that are in some way, shape, or form interested in the same thing. They're some way related, and they get together in a social or virtual environment to be able to share that information. Now, with the use of technology, whenever you do something like this, there's going to be the issues of safety and security that have to become a concern, because it really introduces a whole set of concerns that we should have. We've obviously got viruses and malware, and that's what a lot of people tend to jump to very quickly. In the news recently, if you've been paying attention to any of that, there's a lot of privacy issues, a lot of data breaches that have been occurring, so that certainly can become a concern. There's issues of health concerns. When we use technology, we have the issue of form factors of having to type on the keyboard repetitively. That can become an issue because we can develop carpal tunnel syndrome. At the same time, if we stare at the screen too long, we can develop eye strain. So there's health concerns as well. And then there's environmental issues. What happens when we replace a computer in 2, 3, 4 years? That old computer's got to go somewhere, and oftentimes it goes to landfills. And there's various components that oftentimes make up electronics that can be harmful to the environment. As far as safety and security, there's the idea of green computing. And when I think of green computing personally, I tend to think of money. I want to reduce how much it's going to cost to run a system. So a lot of times you'll set your devices, you'll see your screen go to sleep after a period of time for inactivity. You're saving yourself money by doing that. Basically because you're reducing the amount of electricity that you're using. So there is this idea of green, but like I said, I tend to like to think of it in terms of saving money. As far as strategies to improve how green you are, you can certainly recycle things. In other words, just because a computer is 3 years old doesn't necessarily mean you have to replace it right then. You can go ahead and extend that a little bit longer. Once you do decide to replace it, you don't necessarily just throw it away. There are places that will take these and try to recycle them. Use energy efficient hardware. Use those energy saving features. The regulating manufacturing process can be done, and in fact is. For example, in a lot of cases, some places do not allow lead-based solder to be used. Solder is the component that allows us to attach different metal components to one another, so wires to PC boards and things like that. We can extend the life of computers, something I mentioned previously, and we can also donate or properly dispose of replaced computers. Now the chapter kind of moves on to programs and apps and tries to draw a distinction between system software and application software. I mentioned in the introduction some texts will approach this slightly differently, and they'll actually have 3 categories, and the third category being utility programs. So you can see that in this text it's kind of combined operating systems and utility programs under system software. Essentially, the system software is the software that allows us to interact with the hardware. It allows us to adjust the screen resolution. It allows us to install programs. It allows us to install printers and things like that. So it's what really allows us to interact with the computer itself and start programs, close programs, save files, all of those types of things. Application software tends to be the stuff that we're really interested in. In other words, if we want to play music, we don't use the operating system to play the music. Rather, we use the operating system to open the application that we want to be able to play the music from. We use the operating system to be able to open up the browser to be able to access the website that we want, and so on. So application software is really the software that we want to be able to accomplish some goal. As far as programs, how do we get them onto our system? It really depends on the operating system that we're using. For example, in Android environments and Apple environments, it's as simple as downloading an app in a lot of cases. There's not a huge process. It takes care of the installation process for us. In a lot of Windows-based processes or installations, we have to go through this formal process of launching an application installation or setup program that goes through the process of adding the files that we need to the system, making modifications to system files that are necessary in order for that application to be able to run. And then once complete, we may have to do some updates or do a restart, things like that. Once the program is installed, we can go ahead and run it and work with it in the way that we need to be able to accomplish the tasks that we want to accomplish. And that's pretty much it. How are these programs and apps developed? Well, somebody's got to do it, and that's a program developer, programmer, application developer. Um, and this can range anywhere from a person that's stuck in a dark basement somewhere that works alone, never talks to people, all the way to the other end where it's a global effort of programmers that are working together and collaboratively 24 hours a day, 7 days a week, depending on the size of the program and the budget and things like that. These are people that are usually really, they're very methodical. They have a very structured approach to how they look at things, and they're able to see a program in a way that most people never will have the opportunity to. And their job is to essentially take the specifications for the program and to develop that into the environment that we like to use. How do we get all of our systems to connect and work together? Well, that's through networks, and these networks communicate using a variety of different protocols. So, for example, a web server is going to use the HTTP protocol. File transfer protocol, FTP uses file transfer protocol. Email is going to use SMTP, for example. So there's a variety of different types of protocols that allow us to communicate from one computer to another computer, which becomes a network. So a network, by definition, is a combination of two or more computers. And the reality is we almost all operate in some sort of a networking environment. Multiple types of networks every day. Whether we're visiting chat rooms, we access email, FTP, news groups, internet, video conference, voicemail, etc. These are all examples of communicating across a network. So uses of society. Let's see. Communication networks continue. Communication devices is hardware capable of transferring items from computers and devices to transmission media and vice versa. For example, if you look at our example here, we've got a computer in the bottom right there that can communicate with that cable modem. Let's assume it's a cable modem. That cable modem is going to communicate with the ISP out there on the internet. When we were requesting information, it looks like a map that's on that monitor. When we're requesting, say, a Google map, we're going to ask for maps.google.com. That's going to go out there onto the internet. It's going to pull back from a server somewhere, a Google server, and it's going to pull that information back down. So technically it's a network. We've got two or more computers that are connected to each other to be able to pull that information. That information is going to go across a wire. It's going to go across wireless radio signals, something to be able to transmit that information back and forth. Examples of wireless communication. Most of us are familiar with Wi-Fi. First thing we do when we go to the mall or we go to Starbucks or McDonald's or whatever is you connect to that Wi-Fi, and that's what we do because we're getting a better, faster connection that way. But there's other types of wireless connections. There's Bluetooth, which is really a cable replacement technology. This is something that has much shorter range, whereas Wi-Fi might have, depending on the conditions, up to 100 meters in range, give or take. Bluetooth has much shorter range. It's seen as a cable replacement technology, so range is usually only a few feet. Oftentimes it can be used within a single room. It can replace cables between a computer and a Bluetooth-enabled printer. It can allow for a connection between, say, a tablet and a Bluetooth keyboard. It can allow you to connect your cell phone to your automobile so that you can send and receive phone calls through your car rather than directly through your phone. So Bluetooth is really a cable replacement technology, shorter range, and it can be quite convenient in certain situations. Then there's cellular radio and things like this. So there's a lot of different examples of wireless communications. Again, we already talked about this just a moment ago, but a network is a collection of computers and devices connected together via communication devices and transmission media. So in this example, we have our various collection of computers, our laptop client, a server, a printer, a client. So these are all the computers, and our device is a centralized device here. In this particular case, it looks like probably a wireless modem. So it has a wireless antenna, the modem itself. So this is our device, and then connected together via communications devices and transmission media. So the media is this wire here, this wire here, this wire, and wireless here. So radio waves are our wireless media, and our transmission, our wire here, our network cable, is our transmission media in this image. As far as different types of networks, home networks, business networks, a lot of them use the very same technologies, the same protocols. There's not a lot of difference there. The reasons behind them may differ slightly, and certainly the hardware is going to be different. It's not unusual to reboot your home router periodically, fairly regularly. In a business network, you really don't want to be doing that very often. You want to avoid that as much as possible. But a lot of the ideas, the concepts behind the networks are exactly the same. We want to be able to share hardware. We want to be able to share files. And that's the idea behind both networks. We share devices, we share files, and that allows us to reduce our costs and make things more convenient. So for example, we don't want to necessarily, if we've got 10 computers, we don't want to buy 10 different printers so that we can print from each computer. We buy one printer and share that printer on the network with all the devices, whether that's at home or at work. And that way we only have to have that one printer, and we maintain that one printer. Uses of technology in society, it'd probably be quicker to talk about where computers are not used. And honestly, I couldn't tell you where that's the case. I think computers are really kind of diving into virtually every facet of what we do. Various industries, they're used everywhere, whether it's manufacturing, it's healthcare, it's entertainment, science, retail, farming. It's used virtually everywhere. And so I don't think that anybody can really get a strong education without including some aspect of technology education involved, without some aspect of technology in their education. You need to have at least a basic understanding. That doesn't necessarily mean you have to be a computer programmer, but you do have to have some sort of an appreciation for technology, what it can do, and the role that it can play in your particular field. As far as some of the users, whether you're at home, you're working in a corporate business, you're a power user, you're on the go, it really does everybody, because it's in virtually every commercial environment. It's going to be used by virtually everybody. So the specific uses that we might have may differ depending on whether or not you're at home versus whether or not you're at work. More pleasure versus more productivity type work. But the reality is we're all going to be using technology in some way, shape, or form to a lesser or greater degree. So this chapter is pretty kind of a general overview of the entire text. So hopefully, if there's some areas that are very comfortable to you, you'll be able to skip over those areas a little bit more quickly. If an area was not quite as clear to you, you're probably going to want to spend a little bit more time on that respective chapter. But in this chapter, we talked about basic computer concepts. We talked about the IPO model, input, processing, output. We talked about memory and storage. We talked about the internet and the distinction between the internet and the World Wide Web. We talked about some of the issues related to technology in terms of security, in terms of safety, in terms of effects on the environment. And then we talked about the uses of technology applications in society and the different fields that are affected, the different types of users that we have, things like that. So that is that chapter in a nutshell. It's a pretty straightforward chapter, I think, over digital literacy. Hopefully the plan is that I'll be able to create one of these for each chapter over the course of the semester, and hopefully if you can kind of follow along at home if you miss class, or you can go back and review it if you need to. But no promises there. I'll do the best that I can. If you have any questions, send me a message or an email, and I will try to answer it as best I can. Thank you, and take care.